Hello everyone. My name is Taewoong Kim. I'm a software engineer at SK Telecom. SK Telecom is the largest telecommunication company in Korea, and I'm here to introduce about Ceph QoS and some related works done by us and some related works in progress. Over the past few years, SK Telecom has developed all-flash Ceph storage. We try to optimize Ceph for all-flash environment, and we have contributed some code. You may be wondering why a telecommunication company has interested in all-flash Ceph. SK Telecom has subsidiaries SK Broadband and SK Hynix. SK Broadband is internet service provider, and they service multimedia service to its customers. The company needs high performance storage to service high-resolution multimedia. SK Telecom also needs high-performance storage infrastructure to build a 5G network. SK Hynix, a manufacturer of flash memory and solid-state disk, so the company can supply SSDs to make all-flash storage. We thought SKT's ICT companies could get synergy using open source storage Ceph and our SSDs. It's the story about why we started developing all-flash Ceph. Currently, we are contributing to Ceph by participating in development of QoS function and deduplication function, so on. We built a private cloud for developer using Ceph, and we also plan to use Ceph to build a virtual desktop infra using Ceph. I think it's a relationship with benefit to each other. We contribute to Ceph and we use Ceph for ourselves. Today's software-defined data center is using virtualization to use resource efficiently. In the case of storage, shareable storage like Ceph build a consolidated environment and service to many VMs and many tenants. Many clients with various requirements will compete with each other to use shared resource, and they will be impacted and influenced by each other. So it's hard to isolate the VMs, and therefore it's hard to meet clients' various requirements. For example, services or clients with high priority can get serviced properly if there are several noisy neighbors who request many resources and occupy the most of resource of storage cluster. And software-defined storage like Ceph provide many features. They offer auto-recovering or rebalancing and scrubbing, so on. However, another problem comes from this. These storages offer various functionality, but they need additional background operation for that. These background operations compete with client programmed I/O operations. For example, Ceph will automatically try to recover when there is a disk failure or node failure. recover operations may interfere with the operations of the client, and client may not meet the requirements. Conversely, excessive operations of the client could delay the recovery job and increase the possibility of data loss, because another failure could be occurred during the recovering job. Therefore, we need proper resource allocation method. These things are the reason why we need QoS, which schedules the request along administrators' pre-configured policies. Recently, priority queues that adopt MCRAC algorithm have been introduced in Ceph to support QoS function. Ceph uses the priority queue for QoS support. The request received by messenger is included to a priority queue in a shard according to the request page number. Previously, there were weighted queue and prioritized queue as type of priority queues. These were only two types. There were only two types, and the user can select one among them and can use it. Recently, MCRAC OP-class and MCRAC client priority queue have been added for more sophisticated QoS support. The priority queues can be configured simultaneously on min, max, and weight basis. So sophisticated QoS configuration can be set for client or operation type. Another priority queue, MCRAC full priority queue, is now under developing by SK Telecom. Existing MCRAC priority queues cannot set different IO per second for individual client or pools. These can set just the same QoS setting for all clients. When the MCRAC full priority queue development is completed, the QoS parameters for each pool can be set individually. Of course, it also supports QoS setting according to operation type. Currently, it is just for pool unit, but we will gradually expand the function to enable individual client or IBD unit setting. Ceph uses the MCRAC algorithm for supporting QoS function. So we needed to know what MCRAC is in order to understanding Ceph QoS. There were many QoS studies for CPU or memory, but not enough for I/O scheduling. However, MCRAC was designed for I/O scheduling. MCRAC supports reservation and limit-based control, as well as proportional share QoS control. This means that you can allocate weighted-based share, or you can set guaranteed minimum IOs for a particular client, or you can limit the maximum IOs. The basic structure is similar to SFQ algorithm because MCRAC is a kind of pair queuing algorithm. It uses time tags and multiple real-time clocks to determine which client request to be scheduled. Each time the request arrives at a server, MCRAC adds 3 kinds of time tag to the request, support, throughput, or latency, so on. and next one is test Ceph QoS and OIU structure in various environment. We wanted to work closely with the community. Thank you for listening my presentation. Thank you. Any questions?
Thank you for the talk. Do you see this DM clock as being applicable to other Ceph's projects like Ceph FS for the file system in particular, using it for the metadata server to manage the client requests? Do you think we can use this DM clock quality of service for the metadata server to provide quality of service to the metadata requests of the clients? Have you thought about this?
We don't have plan not yet to support file system or MDS server, but we think we will make some some universal unit support QoS. That means we want to set we want to support more than pool. We want to support IBD or some file system or directory basis QoS, but we don't have exact plan, not yet.